Mr. Tarou, in this video, we're going to do two advanced problems dealing with sum and difference identities in trigonometry, or compound angles. Our first problem we're going to take a look at is 2 times the cosine of x plus 2 sine of x, and we're going to figure out what type of transformations we need to apply to the function y is equal to cosine of x to get this function, find the values of a and basically k, a vertical stretch and a horizontal slide that's going to make the parent function of y is equal to the cosine of x line up and match this function of y is equal to 2 cosine of x plus 2 sine of x. And for our second problem, we're going to take a look at the arctan of 4/3 minus 2 times the arctan of 1/2 and figure out what is the exact value of this expression without using a calculator. So let's get started. Now, for our first example here, we're looking at, as we said, 2 times the cosine of x plus 2 sine of x is equal to k times the cosine of x plus a. We're looking for a sort of a magnitude of vertical stretch, or a k value, which is greater than 0, and an a, which is a value that's between 0 and 2 pi. Now we have one equation with two unknowns. We have an unknown of a and we have an unknown of k, and that's what we're trying to obviously figure out as we see with our directions here on the side. And normally we need two equations to solve for two unknowns. Let's see how this works out. So on the left-hand side here, we have a pretty simple expression of 2 cosine of x plus 2 sine of x. That's not really going to get any simpler unless you just want to factor out that common factor of 2. But on the right-hand side, we have k times the cosine of two angles being added together. And we just learned that the cosine of two angles being added together is equal to the cosine of the first times the cosine of the second minus the sine of the first times the sine of the second. I'm not quite sure why I'm writing this with a laser pointer, so let's get this down to ink. And of course, we're going to remember to include those parentheses around what was the cosine of x plus a, because it's turning into two terms. And now we're going to distribute the k. And maybe just give myself a little bit more room here. So we have k times the cosine of x times the cosine of a minus k times the sine of x sine of a. And this is equal to 2 cosine of x plus 2 sine of x. So we have this one equation with, again, the two unknowns of a and k. But these are unknown constants, not an unknown, not just a variable like the variable of x is going to be changing, as our independent value that we can plug anything we would like in. The a is going to be some kind of constant. The cosine of a is a constant, and thus so is k. So if you haven't seen one of these problems before, it can be kind of confusing. It was to me, actually, the first time I saw this. But we have two sides here to our equation, and the left side has a cosine of x, and we have a cosine of x right here. And we have an unknown coefficient for that cosine. And over here we have the fact that the cosine of x has a coefficient of 2. Well, that's actually going to help us set up a system of equations. We're going to go ahead and identify that, yes, we have an unknown constant on the right-hand side of the k and cosine of a, and we're going to match that up with the 2 and write this equation of 2 is equal to k times the cosine of a. Now, we also have with the sine of x a sine of a and a k, but a is going to be, like I said, that constant. So the sine of a is a constant times a constant, and that's going to be equal to, well, just another constant. So we're going to recognize that we have on this second term here a coefficient of negative k and sine of A, and we're going to match that up with the coefficient that we have over here, which is that we have a factor or coefficient, excuse me, of positive 2 in front of the sine, and we're going to write the fact that, well, 2 is equal to negative k sine of A. Now, what are we going to do with this? Well, we're going to come over here and see that if we divide, because now we have two equations and two unknowns, and when we have those two equations and two unknowns, we need to bring those together, right? Kind of fall back on what we learned way back in algebra, which is solving systems of equations with substitution and or linear combination. And we're going to work with and set up a substitution, and we want to arrive at a trig function that's going to be fairly easy to work with, like your sine, your cosine, or your tangent, which is sine over cosine. So with our equation here of 2 is equal to negative k sine of A, and over here we have a cosine of A, let's do a substitution through our variable of k, because it's fairly easy to solve for, and we're going to have, working with our first equation of 2 over the cosine of A is equal to k. Now, if we bring this in, this expression of 2 over the cosine of A into our other equation and bring together the system through substitution, we're going to have, with our blue pen, 2 is equal to negative k, which is 2 over cosine of A times the sine of A. Oh, well, okay, so now we've got 2 is equal to negative 2 times the sine of A over the cosine of A is equal to the tangent of A. And dividing both sides by 2, we have negative 1 is equal to the tangent of A. And doing the inverse trig function, we have arctan of negative 1, which is equal to A. We can say that A is going to be, remembering now, tangent can be negative in quadrant 2 or quadrant 4. So we're looking at A as a possible value of either 3 pi over 4 and or 7 pi over 4. So I'm actually pausing to think about the unit circle. That's terrible. Now, both of those answers are meeting our requirement that A needs to be between 0 and 2 pi. Are they both going to be acceptable? Or, remembering that we have a restriction here on k, we want our factor, our vertical stretch factor, to be a value which is positive. We need k to be positive. Let's take these values of A and put them back into, either one of these is fine. We're going to go ahead and put them back into our first equation here of 2 times the cosine of A and see what we get. So we've got, let me get a different color pencil here. We'll do it in white. We have 2 is equal to k, and we're going to be working with A, which is equal to 3 pi over 4. 2 times k times the cosine of 3 pi over 4. Well, that's going to give us 2 is equal to k, and the cosine of 3 pi over 4 is negative square root of 2 over 2. And when I multiply both sides by, well, the reciprocal, I'm going to have negative 4 over the square root of 2, which is equal to k. And maybe, yeah, we need to clean that up a little bit, but why bother? Because we need to reject this value. This is not greater than 0, so we're going to have to reject this value of A, because while it is between 0 and 2 pi, it's not yielding us an answer of k, which is greater than 0. So let's go ahead and take this out and see if the value of A being 7 pi over 4 gives us a acceptable value for k. So again, we've got, with our first equation, 2 is equal to k times the cosine of, this time, 7 pi over 4. We're going to get 2 is equal to k times the cosine of, oh hell, I just said that. So cosine of 7 pi over 4 is equal to the square root of 2 over 2. and multiplying both sides by the reciprocal, we have k, we have an eraser, we have k is equal to 4 over the square root of 2, just do a little bit of rationalization here, and we've got 4 square root of 2 over 2, or that k is equal to 2 square root of 2. Okay, excellent. Now we have a value of k which is greater than 0, and we have a value of a which is between 0 and 2 pi, which means that we have found the transformations that will map the cosine function y is equal to cosine of x onto our given function of 2 cosine of x plus 2 sine of x, which is another way that this problem can be worded. Otherwise, we are looking at finding the values of k and a, which make the two sides of this equation equal. So we have our final answer. We have the variables identified, but let's go ahead and write this out as 2 cosine of x plus 2 sine of x is equal to 2 square root of 2 cosine of x plus 7 pi over 4. Excellent. Now, let's go on to the second example, where we have the question of the request of finding the exact value of arctan of 4/3 minus 2 times arctan of 1/2 without any additional information given, and you're not allowed to use a calculator. We want an exact value, not a rounded off value that we're getting from our calculator. Okay. How are we going to approach that? What is this equal to without using a calculator? Well, what do you get from an inverse trig function? You get an angle measure. And the arctan of 4/3 is going to give you some kind of angle measure, and the arctan of 1/2 is going to give you some other type of angle measure, which then is going to be multiplied by 2. So arctan of 4/3 minus 2 times arctan of 1/2, we need to recognize that that is a difference of two angles, one of them actually being a double angle equation. But we're going to use the difference identity for tangent to help us evaluate this expression. So we're going to need to remember that and realize that arctan of 4/3 is once again going to give us some kind of angle. So now if we take the tangent, apply the tangent function to both sides of this equation we have over here, we have 4/3 is equal to the tangent of not theta, but alpha. Because I didn't define a theta, my problem. So, and over here, we've got the arctan of 1/2 is going to give us some kind of angle measure. And we're going to apply the tangent function to both sides and say that 1/2 is equal to the tangent of beta. Okay, so now if I take my expression here and I look at this as a tangent of alpha minus 2 beta, and look at the other side of this identity, which I'm probably not going to have enough room to write here, so let's slide this over. That's going to be equal to the tangent of alpha minus the tangent of 2 beta, which is then over 1 plus the tangent of alpha and the tangent of 2 beta. Now, see, what's working well for us here is that if we see this arctan of 4/3 minus 2 arctan of 1/2 as a difference of angles, and we turn to that difference identity for the tangent and look at what it's asking for, we can see that we can work with the tangent of alpha, which is equal to 4/3. So let's go ahead and put that in here. And then minus, okay, so we're being asked for, the identity is asking for the tangent of 2 beta, a double angle. But we don't know what the tangent of 2 beta is. We know what the tangent of beta is, and that's 1/2. We don't have the tangent of 2 beta. So we're going to also now with this interesting problem, we're going to not just work with the sum and difference identity for tangent, but we're going to have to pull out our double angle identity. So let's say here, and we've got that the tangent of 2 beta, if you remember this identity, otherwise you can write this as the tangent of beta plus beta and derive this on your own, but it is 2 tangent of beta over 1 minus the tangent squared beta. And it's a very easy identity to rederive for yourself, because it's really just going to be the tangent of beta plus beta is the tangent of beta plus the tangent of beta over 1 minus the tangent of beta times, well, tangent of beta. And here we can see with our double angle identity that yes, we can write the ratio or figure out what the ratio is for the tangent of 2 beta, even though we don't know what beta is or even what the measure of that angle is, which is twice as big. So we're looking at 2 times the tangent of beta, which is 1/2 over 1 minus that 1/2 squared. Oh, okay, so we have 2 times 1/2 is just 1 over, and we've got 1 minus 1/4, which is 4 over 4, minus 1 over 4 is, whoops, hello, didn't mean for the eraser to come on, 3, or that time again, over 3/4. And that is going to give us an answer of 4/3. Oh, okay, well, this is going to kind of end very quickly here. But as long as we see the approach of this problem where we see an expression which looks like trig, and it is, but really it's just a difference of 2 angles, and we're going to use that difference identity for tangent to work it out. Let's keep going. Let's see what happens. We have 4/3 minus 4/3. That's going to be over 1 plus tangent of alpha, which is really kind of an unimportant what's in the denominator now for this problem, because the numerator is 0. But however the denominator simplifies out, it's 0 over something. So the tangent of alpha minus 2 beta is equal to 0. Now here's where we start to build back into that original expression where we're asked to evaluate arctan of 4/3 minus 2 times arctan of 1/2. We're going to take this function that we have now, tangent of alpha minus 2 beta is equal to 0, apply the inverse trig function to both sides, and we have alpha minus 2 beta is equal to arctan of 0. Now, I'm going to be looking at this problem as the idea that we have a ratio for tangent which is positive, and tangent is going to be positive in quadrant 1 and quadrant 3. 1/2 is also can be with that ratio. The tangent can be in quadrant 1 or quadrant 3. I'm working with this as if we are in quadrant 1 and working with arctan as it is acting as where it's acting as a function, not a relation. So we're going to be looking at this as alpha, okay, try that again. Alpha minus 2 beta is equal to 0. And I'm only looking at the 0, not a plus 0, sort of like a pi n, where n is an element of integers, because I'm doing this problem with the assumption that tangent is acting as inverse tangent is acting as a function and not a relation, by the way. So do what is appropriate in your class and what your teacher is asking for. Yeah, so we have that alpha minus 2 beta is equal to 0. And, well, wait a minute here. We defined or sort of said let the arctan of 4/3 equal alpha. And probably for good measure should have that in my work here. We're going to let arctan of 4/3 equal alpha to work through this problem. And we're going to let, because I did basically define new variables, arctan of 1/2 equal beta, and we're going to substitute those back in. So that alpha, arctan of 4/3 minus 2 beta, which was with arctan being equal to, with tan of 1/2 being equal to beta, we have our 2 arctan of 1/2, and without the aid of a calculator, we got an exact value answer of 0, which is a little bit anticlimactic. I always hate getting like just a 0 or a 1 as our final answer. But that is the end of our 2 examples. I'm Mr. Drew. Go do your homework.